Hello and welcome to the September update from the Tau team, and it's on to your Q&A questions for the month. Cheers. The first question is from Sir Andrew, and he asks, how does Tau deal with very complex problems, and what methods does it use to handle these challenges in real-world situations?
It is all about optimizing the Tau language backend. Something that we didn't invest much now in doing because we prioritize to release something. But yes, in the future, we will, of course, invest a lot in optimization.
All right, fantastic, Ahad. And another question from Sir Andrew is, could you tell us more about Henkin quantifiers, software specification language to distributed network specification language? Cheers.
Yeah, so when you define a whole network, so there are many clients in this network and they send messages to each other, and each of them has inputs and outputs to their own local user. And there is a complex structure of dependency. So, for example, the output of one client cannot depend on the input of another client unless there is a message in the middle. And to support this, to express this, first order logic is not enough. You need what is called Henkin quantifiers that are able to express such a dependency.
All right, fantastic. Thanks, Ahad. And the next question is from Gabe, and he asks, research version 0.25 contains incomplete proofs, lacks empirical testing and case studies, and is ambiguous, for example, with homomorphisms. When can we see an updated version addressing these issues?
That's right. It's very drafty, although some parts, maybe the important parts, are well written, are correct, at least in this sense. But yes, it's a lot of effort to bring everything to a final form, and it is not in priority. The priority is, of course, to release the products now.
All right, thank you, Gabe, and thank you, Ahad. And the next question is from Agoras for Life. Get in there. Given models like OpenAI's O1 can solve problems where there are clear answers when you throw a computer at it, what will Tau's advantage be?
So models like O1 take longer to produce answers and use a lot more computational resources to improve the fraction of answers they get right. But that fraction is nowhere near 100%. I think they're claiming 89% of the cases they'll come up with the right solution. That leaves 11% of the cases where the model doesn't come up with the right solution. And the goal of Tau and the goal of traditional AI or logic-based AI is to produce answers 100% of the time, and also, most importantly, produce explanations for why that is the right answer. So we give you a step-by-step explanation for why this is the right answer, which is something that LLMs will never be able to do. So that's the main difference between us and O1.
Fantastic. Thank you, Karim. And Dana's next question is, Fola, you said in a business discussion that many don't believe logical AI is possible. In light of the working alpha release, what Tau applications could remove all doubt for VCs? Well, as you guys know, many people want to be shown rather than told. So I think just any app that we build that utilizes some of the unique features of Tau language would solve that massive problem. So any app that we create that can, for example, refer back to its own sentences, I think is a huge, huge milestone that will sell any VC. When I say sell any VC, I mean convince them that it's possible. But at the same time, pretty much any application that we can work on that utilizes any of the unique functionality of Tau languages is what is going to help us do a lot of the groundwork in getting VCs over the line. And the last question for the month is, suppose I want to specify a neural net, evolutionary optimization, or reinforcement learning. Is this going to be possible using Tau language, and will it require an extension?
Yes, thank you for the question. So the envisioned Tau language in the end will provide the theoretical capability to implement basically any computer program which can be implemented using other programming languages. And as a result, in neural net and the other examples you mentioned can in principle also be specified using the tau language at the end. And practice will show which layers of abstractions we need to add to the tau language in order to make it usable and best suited for the user base.
All right, that about wraps it up for the Q&A questions for September. Thank you so much for joining in, tuning in, and sending in your questions. We'll see you on our socials. Cheers. Bye.